All right, this video is writing a vector in terms of its magnitude and direction. So we have a vector v, and the direction is angle theta. And that is from the positive x-axis, so think of it as the horizontal axis. The vector can be expressed in terms of its magnitude and direction as using this equation. So reviewing, this notation refers to your magnitude or the length of your vector. This notation here represents the direction in which the vector is going from the positive x-axis. So here's an example of a vector. Here's the origin. Here is our vector as a linear combination. The direction at which it goes, it starts at the x-axis, and then the length of the vector is how long that vector is in that notation. So a vector that represents the direction and speed of an object is called the velocity vector. So we're going to show you in the next example 8, we express wind's velocity in vectors, magnitude and direction. So go ahead and just highlight the velocity vector when you identify the direction and the speed of an object. So here's example 8. Write a vector whose magnitude and direction are given. So to help you out, I did have that figure already sketched out in our notes. So the wind is blowing at 20 miles per hour in the direction of 30 degrees northwest. And we want to express its velocity as vector v in terms of I and j. So we're going to be using that formula on the previous slide. So this formula right here. So the first thing we have to find out is what is the direction in which this angle is going. So we need to find the direction angle. Again, it's from the positive x-axis. So this distance right here is 90 degrees. And now we have another 30 right there. So the direction in which this vector travels is 120 degrees from the positive x-axis. So again, this angle right here, our angle theta, is 120 degrees. The second thing we need to find out is the length of the vector. So here is our vector, and it is 20 miles per hour. So the length of that vector is our 20 units. Now we're ready to use our formula on the previous slide that I highlighted here in the red. So here's our equation. So vector v equals the magnitude or the length of the vector, cosine of the angle I plus the vector magnitude again, sine of the angle, and then j. So now we're going to substitute in. So vector v, the magnitude is the length, 20, cosine, the direction angle, 120 degrees, I plus magnitude, sine, substitute in your direction angle, and then j. Now we think back to our unit circle in Unit 4. Here's our unit circle. We have the angle 120 degrees. What is that ordered pair? That's negative 1/2, comma, square root of 3 over 2. Remember, this is the cosine value, and that's your sine value. So we're going to substitute those fractions in. All right. So vector v equals 20, and now we look for the cosine of 120 degrees, which is negative 1/2, plus 20. The sine of 120 degrees exactly is the square root of 3 over 2. Put our I and our j in. And now we simplify those fractions. So 20 times negative 1/2 is negative 20 over 2 I plus 20 square root of 3 over 2 j. Continue simplifying. Negative 20 divided by 2 is negative 10 I. 20 divided by 2 is 10, and then square root of 3 j. So that is the vector. As that represents the wind's velocity in terms of I and j.